Okay, we're going to go through a few of these. So these are probably the hardest problems that we have to deal with, but they're not too bad if we get a plan going on. All right, so let's write down all the stuff that we have. So question number 1, we have our equation. So 2CO plus 1O2 gives us 2CO2. We know that we are starting with our 174 grams of carbon monoxide. So carbon monoxide is CO. We're going to end with oxygen. Oxygen is going to be CO2. And we want to find molecules of oxygen. So we need to have a plan for this. What we're going to do is we're always going to convert to moles or from moles. So the idea with this is if we look at our map, we're going to start at 704 grams of CO, and we want to go to moles of CO. And then our end, we want to end in molecules of O2. So the middle step is always going to be the mole. So we're going to go moles of O2. So this is kind of our process. We have 3 steps: step 1, step 2, step 3. This is our start. This is our end. So we're going to be using our mole map to kind of fill in the middle bits. All right, so let's go ahead and do that. Okay, for the first one, we're going to start off with 174 grams of carbon monoxide, CO. So we want to go from grams to moles. So from grams to moles, we're going to use our molar mass. So 1 mole over so many grams. We have carbon monoxide, so C and O. Carbon's 12.01, oxygen 16. So we just add these, we should get 28.01. So that's going to be our mass. All right, for our middle step, we want to make sure that we're putting, the substance CO for this. All right, our next one, we want to go from mole to mole. So the idea is we're going mole of CO to mole of O2. So CO to O2, we have kind of our ratios here. So we're looking at this one and we're looking at this one. So we want to put CO on the bottom. So we have 2 moles of CO for every 1 mole of O2. All right, we check this out. Moles of CO and moles of CO cancel out. And then our last bit, we're going to go from moles of O2 to molecules. So again, we start with moles and we go to molecules. We follow our map. Avogadro's number on top, 1 mole on the bottom. So we have 6.022 times 10 to the 23rd over 1 mole of O2. Moles of O2 cancel, and then we just multiply and divide. So our 174 times Avogadro's number, 6.02 to the 23rd power, divided by the mass, divided by 2. We're getting molecules. So we expect 1.87 times 10 to the 24th molecules of O2. All right, so that's the first one. They take a while, but they're not too bad after. All right, let's look at one more. So the second problem that we're going to look at here is we want to figure out how many liters of oxygen are at STP required for the combustion of magnesium. So our equation we want 1.4 of magnesium's start end with liters of oxygen. Okay, so that's all the information we need. Let's go ahead and go back to the problem itself. All right, so let's look at our plan. We are going to start with 1.4 grams of magnesium. We're always going to go to the mole, so moles of magnesium. If we think about our end step, we have 2 more. We're going to end with liters of O2. So to get to liters of O2, we need to have moles of O2. So that's kind of our plan. This is our start. This is our end. So let's solve for it. We're going to take what we're given, 1.4 grams of magnesium, and then we know the magnesium has a mass of 24.31. So we can say it's 20. Let's get a map. We're going grams to moles. Again, follow this. 1 mole over grams on the bottom. So 1 mole over 24.31 grams. So grams of magnesium and moles of magnesium. These would cancel out. All right, our next bit, we're going to go mole to mole. So we're looking at our ratio here. We have a 2-to-1 ratio. We say 2 moles of Mg for every 1 mole of O2. So we can plug this in. We put the Mg on the bottom. These are going to cross out. And then we're left with the last part. So the last one, we have MgO. So we're going to put in 2 moles of, last step we're looking here, going from moles to liters. So moles to liters, we're going to follow this path. 22.4 liters over 1 mole. And this is going to be oxygen and oxygen, so this crosses out, and we get our answer. So for this one, we're going to multiply and divide. So 1.4 times 22.4 divided by 24.31 divided by 2. So we're going to get a total of 0.65 liters of O2. It's going to be our answer.